guys, welcome to my second video lesson, Geometric Figures. So let's get right to it. So question 1, how do you find the degree of each angle in this figure? So let me get my pointer up. All right, so we're going to start with angle 7 because it is right here with the interior angles. So these interior angles are going to be supplementary. So that means, as you can see in our definition chart, that it's going to add up to 180 degrees. So you would take the two numbers that we already have, 56 degrees and 65 degrees, and you would subtract that with 180, and you would get our angle 7, which is going to be 59 degrees. So we have 59 degrees for angle 7. So we're going to start back to the beginning with angle 1. And angle 1 and angle 7 are corresponding angles, and corresponding angles are going to be equal to each other every time. So that means that angle 1 is also going to be 59 degrees. So angle 2 right here is opposite of angle 56 with a vertical angle. So vertical angles are also going to be equal to each other. So that means angle 2 is going to be 56 degrees. So now we go to angle 3. And angle 3 is going to be corresponding with angle 65 degrees. So, so that makes angle 3 also 65 degrees. And we move on to angle 4. And angle 4 is going to be opposite with a vertical angle of angle 65 degrees also. So that's going to make angle 4 also 65 degrees. So angle 5 is going to be opposite with a vertical angle with angle 7 down here. So that means that angle 5 is going to be 59 degrees. So angle 6 over here is going to be supplementary angle with the angle 65 degrees. So you're going to do the same math from before, and you're going to do 180 minus 65, and you'll get a 115 degrees for angle 6. So angle 8 is going to be supplementary to angle 7, these two. And so with the previous math, we'll get 121 degrees for angle 8. So angle 9 over here is going to be opposite with a vertical angle to angle 2. And so that means we remember angle 2 was 65 degrees. So that means angle 9 is also going to be 65 degrees. And then we have angle 10 with the opposite but also vertical angle of angle 6. So angle 10, remember angle 6 was 115 degrees, so angle 10 is also going to be 115 degrees. And then angle 11 is going to be opposite with a vertical angle to angle 8. And if we remember, angle 8 was 121 degrees. So that means that angle 11 is also going to be 121 degrees. And then we move on to our last angle, angle 12. Angle 12 is going to be opposite with a vertical angle to angle 7. So angle 12 from our very first angle, angle 7, angle 12 is going to be 59 degrees. And there you have our chart that shows 1 through 12 what all the angles are. Okay, so now we have question 2. How do you find angles in a triangle? So you can see we have the angle C and angle B as 74 degrees and 26 degrees. So we know that all triangles are going to equal 180 degrees. So if you take 74 and 26 and subtract them from 180, you get angle 1, and you get 80 degrees for angle 1. So then you get angle 3 and angle 2. They are supplementary. So so that makes 2. I'm sorry. First, we got to do angle 3 and angle 8 because those are going to be corresponding to angle 1. So that makes angle 3 and angle 8 80 degrees as well. So going back to angle 2, if you take angle 3 minus 180 degrees, you get 100 for angle 2. So angle 2 is 100 degrees. And then angle 5 over here is going to be congruent to angle 1, 3, and 8. So that makes angle 5 also 80 degrees. So then you have angle 7 and angle 8. And they are also supplementary. So angle 7 is going to be the same as angle 5, and that is, or angle 2, I'm sorry. So it is also going to be 100 degrees. So then you take angle 4, and it is congruent to angle B. So that makes angle 4 26 degrees, and then angle 6 is going to be congruent to angle C. So that makes angle 6 74 degrees. And there's our little chart for this one. All right, question 3. How do you find the angles in a congruent polygon? So as you can see over here, my math is starting to come up. And you have the equation for a concave polygon. And it is, in parentheses, n minus 2, out parentheses, times 180 degrees. So over here, you can see we have n is equal to the number of sides. So in this polygon, we have 8 sides. And so you can see over here, we have 8 minus 2 times 180 equals 1,080 degrees. And then you take your y's, and over here you add them together to equal 180 degrees, and you get, and you can see my math is kind of going the long way, you get 9y, 21y, and should be 24y when it comes up. And then we'll add all of that together. Let's wait for it to come up, I guess. And you get 54y. So after you divide 54 by each side to get y by itself, you get y equals 20 degrees. So down here, you would take that 20 degrees and substitute it for each y value you have in the polygon. So for 3y, you would get 60 degrees. For 7y, you would get 140 degrees. And for all your 12y's, you would get 240 degrees. All right, so for question 4, how do you get the interior, exterior, and central angles of an n-gon? So as you can see, my math is obviously coming up. N is still equal to the number of sides, and we counted over here, n equals 9. So your interior angles equation is n minus 2 times 180 over n. So you would have 9 minus 2 times 180 divided by 9, and that would give you 140 for all your interior angles. Now your exterior and your central angles, the equation for that is going to be the same, and it's going to be n minus 2 times 360 over 9, or over n. And so you would get the same answer for both the exterior and central angles, which would both be 280 degrees. Okay, question 5. How do you build a tetrahedron? So a tetrahedron is a triangular pyramid that is a polyhedron composed of 4 triangular corners. See down here, we've got 1, 2, 3, 4. 6 straight edges, 1, 2, 3, 4, 5, and 6. And 4 vertical corners, 1, 2, 3, and 4. So that's our tetrahedron. This tetrahedron that we have is inscribed in a cube. So that means that the tetrahedron cannot share any of the faces with the cube itself. And you'll find that the 6 edges you are looking for are 6 diagonal of the 6 faces joining the selected vertices. And you'll also find that you have chopped off the other 4 vertices with a plane right here through its neighboring vertices, leaving behind 4 cuts and the 4 faces. You know, all right here, the 1, 2, 3, and 4, because it chopped it off right here. So, question 6 is what are, and sorry, I'm going to butcher this, Schlegel diagrams. So we already know what a tetrahedron is right here. So an octahedron, this one, is a polyhedron with 8 faces, 12 edges, and 6 vertices. And then I'm gonna butcher this again, icosahedron right here is gonna have 20 faces. So much bigger than just the tetrahedron. So a Schlegel diagram is a polyhedron of a projection, of a polyhedron into a plane figure and a projection of a 4 polytope to a 3-dimensional, 4-dimensional space. Schlegel diagrams are usually used as a means to visualize 4-dimensional polytopes. And that is all I have. Thanks.